Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 12-2 homework solutions on multiplying matrices. For this problem, we're trying to figure out if the product of AB is defined based on these dimensions. So since we have these matching threes in the middle, since the columns of the first and the rows of the second are the same, this will be defined. And that means that the dimensions are going to be the rows of the first times the columns of the second, so 2 by 2. For this problem, we want to know if the product of these two matrices, at least the ones with these dimensions, is going to be defined. So taking a look at the columns of the first, this is a 2, and the 3, the rows of the second, those have a mismatch, so that means that this product will be undefined. For the next several problems, we're trying to find the product if it's possible. It might not be possible, so we always want to double check, and while we're at it, see what the dimensions of the product are going to be. So here we have a 1 by 2 and a 2 by 2. Since these 2's match in the middle here, that means we'll have a defined product, and it will be a 1 by 2, having the rows of the first and the columns of the second. All right, so let's do our multiplication then. So we have just this one row times these two columns. So we have negative 2 times 4 plus 3 times 2. And then we also have negative 2 times 0 plus 3 times 1. And now just to simplify all that, this is negative 8 plus 6, so negative 2. And we have 0 plus 3 is 3. On this problem, we have a 2 by 2 times another 2 by 2. Since the columns of the first and the rows of the second match, this will be defined, and it'll have a 2 by 2 as the product because of these outer 2's here. So multiplying our first row here by each of the two columns, we've got negative 2 times 4 plus 3 times 7. And then we've got negative 2 times 2 plus 3 times 0. Now we're going to dot multiply that second row by each column. So 5 times 4 plus 1 times 7 down here. And then 5 times 2 plus 1 times 0 right there. Simplifying all this, we have negative 8 plus 21, so 13. Negative 4 plus 0 is negative 4. 20 plus 7 is 27. And then this is just 10 plus 0, so 10. We're trying to multiply these matrices together, so let's start by checking our dimensions. We have a 2 by 2, and that's being multiplied by a 4 by 2. So because the columns of the first and the rows of the second don't match up, we actually can't do this multiplication, so this is undefined, and that's just done. To multiply these, we're going to check our dimensions first. We have a 2 by 3 times a 3 by 3. The columns of the first and the rows of the second, these 3's match, so we'll have a defined product. And it's going to have the rows of the first and the columns of the second, so 2 by 3 for the final answer. So we're going to go through and dot multiply this first row by the 3 columns here, and then we'll do the same with the second row. So we've got 5 times 1 plus 7 times 5 plus 0 times 8. Next we've got 5 times negative 1 plus 7 times 2 plus 0 times 0. And then for the last column, 5 times 4 plus 7 times 0 plus 0 times negative 3. Next up, we'll do our second row, dot multiplied by all the columns. So negative 2 times 1 minus 4 times 5 plus 1 times 8. And then negative 2 times negative 1 minus 4 times 2 plus 1 times 0. And finally, negative 2 times 4 minus 4 times 0 plus 1 times negative 3. All right, a lot of simplifying to do here. So we've got 5 plus 35 plus 0, so 40 there. And then negative 5 plus 14 plus 0, so that's 9. Next up, we have 20 plus 0 plus 0, so that's easy, 20. Now we've got negative 2 minus 20, so let's see, that's negative 22 so far, plus an 8 is negative 14. and then this is 2 minus 8 plus 0, so negative 6. And finally, negative 8 minus 0 minus 3 is negative 11. For the next couple problems, we're being given these three matrices, A, B, and C, and we're evaluating an expression with those. So this time around, we've got 1/2 times AB. So let's just start by actually replacing these with the matrices that they represent. So this is 1/2 times the A matrix times the B matrix. And I leave it in parentheses like they gave it to me, but if I wanted to, I don't have to multiply these matrices first. I could distribute this 1/2 to one of these matrices, and that would be totally okay. I'm not going to do it because that's going to give me some fractions that I'm going to have to matrix multiply later, but I could if I wanted to. So I think it's going to be easiest if I just matrix multiply A and B first, and then I'll apply that 1/2 scalar to whatever's left over. So I have a 2 by 2 times another 2 by 2. These middle 2's match, so that means we have a defined product, and it's going to be a 2 by 2 itself. So we've got each row in the first time dot multiplied by each column in the second. So we have 4 times 5 plus 1 times 6, it's 26. And then 4 times negative 2 plus 1 times negative 1, that's going to be negative 8 minus, negative 8 minus 1, so negative 9. Next up, we've got negative 3 times 5 is negative 15, plus 0 times 6, so negative 15. And then finally, negative 3 times negative 2, plus 0 times negative 1, that's going to be 6 plus 0, so just 6. And at this point, I'm going to multiply the 1/2 by everything in here. So that's going to be 13, negative 9 over 2, negative 15 over 2, and 3. On this problem, we're trying to evaluate AC plus BC based on the matrices here. So you could, if you wanted to, just to save a little bit of time, factor a C out of both of these, and then you'd have C times A plus B, and you could add A and B and only have to do one matrix multiplication. But I think matrix multiplication is kind of fun, so I'm going to just kind of play the ball where it lies on this problem. So let me start by replacing AC and BC with these matrices. So we've got A times C, that's this one times this one right there, plus B times C, so this matrix times this matrix. And let's just matrix multiply these and see how it works out. And now in both of these cases we have a 2 by 2 by another 2 by 2. So in both of those cases, because of these middle 2's matching, these will be defined, and the result of both of these will be another 2 by 2 because of these red outer 2's here, the rows of the first and the columns of the second matrix. All right, so I'm going to dot multiply each row in my first matrix by each column in the second, and I'm not going to show the things I'm multiplying together. I'm just going to put the answer, just kind of doing it in my head, but you can write down the work if you want. So we've got 4 times 3 plus 1 times negative 1, that's 12 minus 1, so 11. And then 4 times 0 is 0, plus 1 times 8 is 8. Next we have negative 3 times 3 is negative 9, and then 0 times whatever is 0, so negative 9. And then we have negative 3 times 0 is 0, plus 0 times 8 is also 0. So there's our first result of matrix multiplication. Let's move on to the second now. So we've got 5 times 3 is 15, and then negative 2 times negative 1 is plus 2, so 15 and 2 is 17. Next we have 5 times 0 is 0, and negative 2 times 8 gives me negative 16 for that. Down for my second row now, 6 times 3 is 18, and then negative 1 times negative 1 is plus 1, so 18 plus 1 is 19. And finally, 6 times 0 is 0, negative 1 times 8 is negative 8. So I have two matrices that I'm adding together, and they have the same exact dimensions, so I can actually do this. Let me just add things that are in the same positions now. So 11 and 17 gives us 28. 8 and negative 16 is negative 8. Negative 9 and 19 is 10, and then 0, negative 8 is negative 8. For this problem, we have a softball coach buying equipment for two teams. We've got the coach buying 4 bats, 36 softballs, and 12 uniforms for one team, and 6 bats, 45 softballs, and 15 uniforms for the other. They give us the price, $84 and $20 for the bats, softballs, and the uniforms. I didn't know bats cost so much money, but now I know. We want to use matrix multiplication to find the total cost of equipment for each team. So that means we need to set up 2 matrices and multiply them together. So our 2 matrices we're going to set up. To get the total cost of equipment, we need to basically talk about the amount of equipment bought times the prices of each type of equipment. So we have equipment times prices. So we're going to set up one matrix for the equipment and another for the prices. So just to organize our data in one matrix, the way I'm going to set this up is I'm going to have 2 rows, one for team A, one for team B, and in each row I'm just going to list out the amount of each type of equipment, and I'm going to have columns for those. So one column for bats, one for softballs, one for uniforms. So for row A in this, I'm going to have a 4, 36, and 12. This is representing the bats, softballs, and uniforms for team A. And then row B, team B's equipment, that's going to be 6, 45, and 15. Now I'm going to set up another matrix to multiply by this. To set it up correctly, since this has 3 columns, I need to set up a matrix that has 3 rows so that the columns of the first and the rows of the second will match and I can actually multiply together. So I'm just going to set up a 3-row by 1-column matrix that has the prices of each item, and we'll go in the same order that these columns are going in. So we'll do bats, softballs, and uniforms. So 80, 4, and 20 going from top to bottom. And so now we have equipment times prices in matrix form. Let's multiply this together and see what we get. Now, in order to do this, let me just double check my dimensions. We have a 2 by 3 and a 3 by 1. The 3's match, which was by design, we set it up that way. But this also tells us the dimensions of the new matrix. We're going to have a 2-row by 1-column matrix that's going to have the total dollar amounts that we spent on each of these teams by multiplying this out. So let's do the first row in this first matrix dot multiplied by this column here. So we have 4 times 80 plus 36 times 4 plus 12 times 20. And this will be, again, a 2 by 1 that this is going into. And then my second row times the column. So 6 times 80 plus 45 times 4 plus 15 times 20. And I might be able to do this without a calculator, but what do I have to prove here? I'm just going to do it on Desmos, and we'll make sure we have the right answer. So time to plug all this in. We have 4 times 80. We have 36 times 4, plus we have 12 times 20. Grand total of $704 that we're spending there. And let me just go back and plug in the rest of this. Now I've got the same second number, 84 and 20, so I can just change the first number in this multiplication. So I've got a 6, and instead of 36 I have 45, and this was the number of softballs, and this was the uniforms. Instead of 12, I've got 15 for Team B. So that's $960 total. So Team A, $704, Team B, $960.